update for this opportunity to share some of the work that we are doing here at Robotic, where I serve as the managing director, as was introduced, mainly trying to bring some of these technologies to outside of Hong Kong, actually, so to the global markets. So Robotic is basically a startup in Hong Kong, around 7 years old. And it's building technology to make our urban built infrastructure safer, smarter, and greener. The mission of the company basically is to bring in the latest in AI, big data, robotics into the AI safety analytics platform that we are building and make it much lower cost to do regular inspection and maintenance repair based on that. So basically the customer pain points that we are addressing are property owners, real estate developers, facility managers, registered engineers, building surveyors, as well as government departments, government agencies. And each of them have different types of pain points. And our solution is trying to address all of them. Essentially, the solution we have been working on, we have developed, consists of 5 steps. And the first step starts always with autonomous data capture. Now, here you see the picture of a drone, but of course, it can be various types of robotic methods of data capture. But drone becomes a primary vehicle, particularly for aerial data capture. This particular drone that you see here is the latest development, which can do indoor navigation without the help of GPS signal from satellites. So that opens up the indoor spaces and confined spaces for inspection as well. Now, once you do the autonomous data capture, the next step is the data positioning or localization of data. This is often a big challenge in traditional inspection technologies. And we have some proprietary algorithms to localize the data automatically using the the images, the thermal data, the LiDAR data, and using the GPS markers, we can automatically and accurately localize the data against any building plans or elevation drawings and so on. Once that is done, then the AI kicks in also to identify the defects within the images or the thermal data that we are gathering. So these defects could be cracks, could be spalling, could be corrosion, could be any number of common building defects that you see. And it also classifies into different severity classification. It's a critical defect, major defect, moderate defects, and so on. So after we do that, our cloud platform allows experts to access the data and the AI results, and they review it and confirm that the data is accurate. And then the report can be generated with a single sort of click functionality, which saves a lot of time, actually. And then finally, the reporting and the analytics basically is very rich. And, I can show you how it works very quickly here. So the key components are robotic platform, AI, machine learning algorithm, and digital twin technology, which is easily built through 3D models that can be constructed using photogrammetry or, using BIM models or from LiDAR data. You can also integrate that into the photogrammetry model to get even more spatially accurate, digital twin models. The autonomous drone for GPS-denied environments. This is, again, a latest technology that's been developed that we are integrating with our software platform and globally starting to promote this. So earlier, as you know, drones were only good outdoors where they can access the satellite signals, the GPS signals. But now, without that, using just simply LiDAR, drones can be flown programmatically, autonomously within confined space. So if you have a large indoor stadium, if you have a shopping mall, you have any kind of spaces which needs regular inspection for various surveillance purposes, inspection purposes, you can use this technology now. Now, what are the kind of AI that we are using? So there are 6 different categories of AI that our company is developing. One is the visual AI, where we take any kind of image and identify objects within the image. They could be small, minor, fine cracks, or they could be various features of the image. Let's say in a building facade, you might want to identify the doors and the windows and various segment it according to the various features, and then identify objects within it as per the requirement. Then there is the thermal AI, where we take infrared data and identify hot spots and cold spots and find defects which are hidden from the surface, such as maybe a delamination, maybe a leakage problem or whatever. Then LiDAR data also, we use AI for, again, constructing 3D models and various localization and measurement purposes. Vibration AI is where we use IoT sensors to monitor various electromechanical systems within buildings or built infrastructure to do predictive maintenance or predict the likely failure so that we can prevent it. So preventive maintenance and repair can be done using IoT sensors and using AI to detect the anomalies. Similarly, magnetic AI can be used using another type of sensors which basically monitor the magnetic field around any kind of metallic object. In this case, it's a steel rope that carries an elevator, or it can carry cranes, tower cranes. These can be monitored for defects that can cause major catastrophic failures. Then there is microwave AI, which is the latest technology, which, as I told you earlier to the co-panelists, that you can actually see through the objects that you're inspecting and identify various hidden features. Even rebars inside concrete can be detected. Their corrosion condition can be detected. Moisture presence can be detected, and so on. Now, the other technology I was mentioning briefly about is the microwave NDT, non-destructive testing using microwave scanning. So here you can see that is the same kind of technology that is used in GPR, ground penetrating radar, or sometimes in the airports when you do a full body scan to identify metal objects and so on. That is the same technology now we're using for reinforced concrete elements, for example. So it's based on electromagnetic waves being, radiated into the object of inspection, and the reflected waves are analyzed to identify what may be the different features inside, such as metallic rebars, voids, cracks, delaminations, water presence, and so on. I mean, corrosion of reinforcing bars can also be. This particular data you see here, the raw data on the top in form of a heat map, and the color-coded data in the bottom in form of a color-coded representation 3D model of the object that's been scanned. It's basically a reinforced concrete floor with rebars and with some voids that you see in the red spots. And the rebars also shows a lot of corrosion where it seems to have become distorted because the product of corrosion is basically migrating into the concrete porosity. So this is a technology also we are promoting along with the drone inspection or robotic inspection of various built infrastructure, where we identify major defects. We go in for much closer inspection using microwave scanning. This is an overview of all different kind of use cases that we have done in the past. So bridge inspection, roof inspection, tunnel inspection, even signboard inspection in Hong Kong streets using a vehicle with mounted cameras on the roof, which goes on the street and basically picks up all the signboards against the buildings, and then identifies those signboards which may be defective or have structural problems that may be that may fail during a typhoon. Like sometimes, in India, we hear about signboards falling and killing people and so on. So it's a very good technology to ensure safety of signboards, for example. Similarly, as I mentioned, for escalator and elevator safety or bearing and other electromechanical parts like motors and pumps, we have IoT sensors that can collect this one. These are some of our awards and certificates. Over the years, the company has won for its work in AI and this particular field. So I'll close this here.